Today's topic is class 10 ICSE electrolysis. So in this, today we learn about some important terms of this lesson. Electrolysis, electrodes, electrolyte, and electrolytes can be classified into two types. They are strong electrolytes and weak electrolytes. And what is electrolytic cell? So now we are going to discuss about these important terms which we use in this topic, electrolysis. So first we try to understand what is the meaning of the term electrolysis. So here you can see electrolysis. So here, whenever this term electrolysis comes or this term lysis comes, it is decomposition. Decomposition of a chemical compound. And here this decomposition is brought about by the passage of electricity. So that's why this is called electrolysis. So simply, or in simple terms, we can say the electrolysis is nothing but a decomposition of a chemical compound by the passage of electric current. But the condition is you have to pass the electric current through the substance in its aqueous solution or its molten state. So this is the meaning of the term electrolysis. So lysis, whenever comes, it is decomposition, and with the help of electricity you are decomposing the compound. So this is called electrolysis. So the definition will be given like this: the decomposition of a chemical compound by the passage of electricity or electric current through in its aqueous solution, means aqueous solution of that chemical compound, or its molten state, means the substance has to be taken in liquid state. So this is the definition of electrolysis. Then we move to the term electrolyte. What is meant by electrolyte? Now this electrolysis is nothing but decomposition of a chemical compound. But can we decompose every substance? It is not possible to decompose every substance, or we cannot electrolyze all the substances. Only few substances can be electrolyzed, and those substances are called electrolytes. So we can define electrolytes as the chemical compound which can be electrolyzed. That means it has to pass electricity through it in the form of aqueous solution. So through its aqueous solution or its molten state. So if a compound can pass electricity through its aqueous solution or its molten state, that means it should be a conductor. It should be a conductor of the electricity in its aqueous solution, or it can be in molten state, and it has to undergo decomposition. It has to undergo decomposition. It has to decompose by the passage of electricity or due to the passage of electricity or electric current. So if any compound can conduct electricity in its aqueous solution or molten state, and if it undergoes decomposition because of the passage of electricity, then we can call such substance as electrolytes. And these electrolytes, which can conduct electricity through them, first they undergo dissociation. They undergo dissociation to give free ions. So these free ions are responsible for the conductivity of that electrolyte. So let's say, what is this dissociation? For example, if you take sodium chloride. Sodium chloride is an ionic compound, as we know. It contains sodium ions and chloride ions. But because of the strong electrostatic force of attraction, these ions are tightly packed. So when you take these electrolytes or these compounds in aqueous solution or molten state, let's say I am taking sodium chloride in molten state. So when you take this sodium chloride, that means you are heating the sodium chloride up to its melting point around 800 to 900 degrees Celsius. So then this sodium chloride, which has ions tightly packed, so those ions will be separated, Na plus and Cl minus, and it becomes liquid and the particles are free to move. So if you take this NaCl in solid state, let us say you are taking NaCl in solid state. So let us say these are the ions you have in this. If this is Na plus, this is Cl minus, so the arrangement of negative and positive ions in sodium chloride will be like this. But when you take this in liquid state, now as we know, in liquid state the particles are free to move. So similarly, since you are taking these ions in liquid state, now the sodium ions and chloride ions can move easily, or they are free to move. So that's why now the ions are free, but here the ions are not free. So here, since the ions are not free, it is a non-conductor. As long as it is in solid state, NaCl is a non-conductor, it cannot be electrolyzed. But here, sodium chloride in liquid state, it becomes conductor because of these free ions, and these free ions are responsible for the conduction of electricity. Conduction of electricity through a conductor, the conduction of electricity through an electrolyte is due to the presence of these free ions. These free ions are responsible, or these will conduct the electricity through an electrolyte. Now in this electrolyte we have two types, or we can classify the electrolyte into two types, that is strong electrolyte and weak electrolyte. So here strong electrolyte is the one which can conduct large amount of electricity, and weak electrolyte can conduct small amount of electricity. Now again, this amount of electricity it conducts depends upon the presence of free ion. So the strong electrolyte is conducting large amount of electricity, and that depends upon the free ions. So here, since it is conducting large amount of electricity, that must be containing a high concentration of ions, high concentration of free ions. or it contains only ions or only free ions in its solution or molten state. In case of a weak electrolyte, it is conducting small amounts of electricity. That means it must be having a very low concentration of free ions. So it contains low concentration of free ions. Right. So now here you will get a high concentration of free ions because of the dissociation of the electrolyte. So higher the extent of dissociation, higher will be the concentration of free ions. So here we can understand this strong electrolyte will undergo complete dissociation. So when it undergoes complete dissociation, so it gives high concentration of free ions, or it contains only free ions. Because it has completely dissociated and it contains large amount of ions, it can conduct large amount of electricity. So similarly here, weak electrolyte conducts small amounts of electricity. That means it must be having low concentration of free ions because of incomplete dissociation. Because of incomplete dissociation. So these are the differences between strong and weak electrolyte. And some examples of strong electrolyte. Strong electrolyte, we can write sodium chloride in fused state or molten state, or you can take copper sulfate aqueous solution, and strong acids like dilute sulfuric acid, etc., they will be under strong electrolytes. And when you come to the weak electrolyte, we can take like ammonium hydroxide, which is a weak base, and acetic acid, which is a weak acid. So these are weak electrolytes. So this is the difference between strong and weak electrolyte. And we have a term electrodes here. So now when you carry out this process, electrolysis, so you can electrolyze only electrolytes. That means which can undergo dissociation and which can conduct electricity, and because of the conduction of electricity, it can undergo decomposition. And this whole process will be carried out in a container, and this container in which we carry out this whole process is called electrolytic cell. Electrolytic cell. Let us say you want to electrolyze molten sodium chloride. So I am taking molten sodium chloride, that means liquid sodium chloride in this electrolytic cell. Electrolytic cell is nothing but the container in which we are carrying out this whole process. Then we need to pass electricity through this. So for that we need a source of electricity. So here we are taking a battery. Battery or a cell we can take. And in the circuit we have a switch. Then we take some copper wires to connect them, and here also we have some copper wires here, and here we have a bulb to check whether the process is going on or not. And so at the end of these copper wires we attach some metal plates. So these metal plates, obviously they will increase the surface area. Okay, when the surface area increases, the process will be easier. So these metal plates which we are attaching to the terminals of the battery, they are called electrodes. They are called electrodes. And when you switch it on, the electricity passes in this way, and the electricity is going to enter the electrolyte from this electrode, and again the circuit completes through this electrode. and electricity is going to pass through the electrolyte which we have here. Electrolyte in the sense the free ions which are present here. So those free ions will be completing the circuit. So here the one which is connected to the positive terminal, this electrode is called anode, which is positive, and the electrode which is connected to the negative terminal, that is called cathode, and this cathode is negative because it is connected to the negative terminal of the battery. So this is the arrangement, and this is electrolytic cell, and these are the electrodes. Electrodes are nothing but the metal plates through which the electricity is entering the electrolyte and leaving the electrolyte in this way. And the electrode which is connected to the positive terminal, that is called anode, and the one which is connected to the negative terminal, that is called cathode. So these are some important terms which we have to remember in this topic.